Is everyone happy, guys? Okay, I'm glad you guys are happy. All right, so I guess you can read this whenever you guys get a chance. LRAM, RRAM, and MRAM are three examples of Rayman sums. And if in case you're wondering, Chavez, what's a Rayman sum? A Rayman sum is just a fancy word. Well, okay, there's a guy who got credit for finding areas under the curves, and his name was called Raymond. And it's just a fancy way of finding an area under a curve. And the way we do it is we do length times height. So yeah, that's what we do. Length times height or width times height or whatever. It's just a rectangle. All right. As you can see, we're going to have a UH quiz coming up. Not yet, because we haven't finished everything about this. But probably the next time we meet tomorrow, we'll probably get it done, hopefully by then. It says, excerpt from UH, compute the lower Rayman sum. So a lot of people confuse lower Rayman sum for LRAM. It's not. It's not LRAM. It's lower. So what that means, yeah, Viacana's on Zoom today. She said she woke up late. Oh, I just started just right now.
It's like 10:01 and 2 seconds.
Oh, it's because I thought you were gonna come in through there. If not, I would have waited for you. Godinez is mad at me, guys. Tell her not to be mad.
Wait.
They said not to be mad. Yeah. You can, the speaker's on this, but they're over there on that one.
Ruth, where you at? I made a cookie for you.
Red, the one time I don't come.
If everybody was here, I would have made cookies for everyone. But he goes out.
You should leave it in his room and I'll get it tomorrow.
Okay.
I'll be there tomorrow.
All right, you already said you're gonna be here tomorrow. If you don't come in, tisk. All right, guys, lower Rayman sum. So here's what it means. Exaggerate a parabola. Make it big. Exaggerate it. Hey, did you like the video, Godinez?
I did like it.
So there's my parabola, and they're giving me my partitions. So all these rectangles are not equal width. So they're telling me from -1 to -1/4. So here's -1, and here is 1. From -1 to -1/4. -1/4 is like right here. Actually, it's like right there. And the lowest point, it's a lower. So the lower Rayman sum means the lowest point on that interval. The lowest point on that interval is a -1/4. So here's your rectangle. There it is. Now you're going to go from -1/4 to a half. A half is like right here. And don't get tricked. The lowest point between -1/4 and a half occurs at x equals what? No, the lowest point. 0.
The lowest point in the box.
Perfect. So there it is. There's my rectangle, guys. It's different than LRAM. It's different than left rectangular approximation method. This is lower bound. And the reason why we're teaching this one is because UH does it, and professors want you to know about this one too. Between 1/2 and 3/4, 3/4 is like right there. And because between a half and 3/4, it's always increasing, the lowest happens at a half. So there's my third. And between 3/4 and 1, it happens at 3/4. It's a lower Rayman sum. So now we're going to calculate the area, guys. Area of the first rectangle. Let's see. The difference between -1 and 1/4. The difference between -1 and -1/4. That's a 3/4. And the height is -1/4 squared. Yes, I know I could have just taken out the negative and just squared it. But I want you guys to see where it's coming from. This is the first rectangle. Plus the second rectangle, technically, from -1/4 to a half, let's see, that is 3/4. And my height is 0 squared. The y value. plus from 1/2 to 3/4, that is 1/4. And my height is 1/2 squared. Plus from 3/4 to 1/4, that's another fourth. And my height is 3/4 squared. I'm going to take a calculator, guys. It's not letting you see a calculator anywhere. So here's my calculator. Oh, by the way, guess what? Oh, no, not chicken, but I ordered 7 calculators of these. That's cool, right?
7, correct?
Yeah, 7 for you guys. All right, I'm just taking my calculator, guys. You guys verify with me. 3/4, 1/4 squared plus 0 plus 1/4, 1/2 squared plus 1/4 times 3/4 squared. All right, if I did everything correct, all of this adds up to 1/4. Now, I make mistakes all the time, so let me know if you got something else besides 1/4, but that's what I got. Are we still okay, guys?
Could you explain how you chose how to draw them?
Can I explain what?
How you chose how to draw them? Like, I understand the equation part. I didn't understand how you drew them.
Like how I drew it?
Yeah, the rectangles.
Oh, they told me right here. You see how it says partitions? So my first rectangle is between -1 and -1/4. That's my first one. And then my second rectangle is between -1/4 and 1/2, which is like 0 there. And then the third one is between 1/2 and 3/4. And then my fourth one's between 3/4 and 1. So 4 rectangles. Now this one says lower, Viacana. So because it says lower, we're finding the lowest point on that partition. So that's why we have a partition with that's why we have a rectangle that's an area of 0, because the lowest point's on the x squared. Okay, we're gonna do another one that's exactly the same. I think the other one's an upper. Oh, no, it's a lower again. So it says compute the lower Rayman sum for the given function. This is sine x over the interval 0 to pi with respect to this partition. So draw as to the best of your ability, sine x, over exaggerate it. Here's 0, here's pi. Right smack in the middle at the highest point is pi over 2. And in green are going to be my partitions. So I start at 0 and then I go to pi over 6. This is like 30 degrees, guys. So it happens pretty quickly. I'm going to say right there. And then 3 pi over 4, that is past pi over 2. In the middle between pi over 2 and 3 pi over 4. So right there. And then finally pi. So everything in green are my partitions. It says lower. The lowest point between 0 and pi over 6 happens at, not everyone at the same time. The lowest point on the curve between 0 and pi over 6 happens at 0. So I have no rectangle there. None, 0, nada. Then I do a partition between pi over 6 and pi over 2. The lowest point between pi over 6 and pi over 2, it's always increasing. Well, the sine x is always increasing between pi over 6 and pi over 2. So that means the lowest point is,
I thought it was pi over 6 and 3 pi over 4.
Oh, you're right. That's correcto. You're correct. That's Spanish for you're right, miss. Between pi over 6 and 3 pi over 4, the lowest happens at pi over 6. I'm always increasing until pi over 2, and then I decrease for a little bit until you get to 3 pi over 4, but pi over 6 is still smaller than 3 pi over 4, the y value. So here's my second rectangle. And then the last rectangle between 3 pi over 4 and pi, the smallest point on the curve is at pi. I know it doesn't feel right. It doesn't feel right, but that's what they want. Lower Rayman sum. This is probably the worst approximation. As you can see, there's a lot of empty space. It's a really bad approximation. Everyone will agree with that. Okay, let's find the area of that one rectangle. All we're doing is finding this rectangle, guys. So let's see. I'm going to take the difference. 3 pi over 4 minus pi over 6. And then the height is sine of pi over 6. And if you remember, I'll write sine pi over 6 for now. It's just a little bit of pre-cal, not extreme. Sine of pi over 6 is a half. So what I'm going to do here, guys, I'm going to do a common denominator. So I'm going to multiply this dude times 6 over 6. And this dude times 4 over 4. Excuse me. So let's see. 6 times 3, 18 pi over 24 minus 4 pi over 24 times sine of pi over 6 is a half. 18 minus 4, that's 14. 14 pi over 24 times a half. 2 goes into 14 7 times. So I'm going to say 7 pi over 24. Did they write it like that? Yeah, they did. I hear someone coming.
They're coming for your child. Not angry.
We're actually supposed to have a walkthrough sometime soon. I just don't know when. Sometime this week, I guess. All right, guys, here we go. Everyone's still happy? You guys look very happy. It says, let's get acquainted with sigma notation. I want you to notice something. 1 over 1, 1 over 4, 1 over 9, 1 over 16, 1 over 25, 1 over 36. So what do you notice? Yeah, the bottom is always squared. So as you can see, I can, this is called a series. Well, we're not gonna, you know what? I don't wanna get you guys into Cal BC just yet. This is just some pattern. We're adding them all up. These are called terms, term 1, term 2, term 3, term 4, term 5, term 6. And what we're doing is we're adding them. So I can express this sequence by this sigma notation. This is called a sigma, capital sigma. And all it means is add. Cool or not cool? Where it says j equals 1, that's where you start. Where it says at the top, where it says the number 6, that's where you stop. This is not the only way to express this sequence. Is there another way? C, yes. How do you, we, what other language can I do? That's it, guys. Huh? Da, what is that? Oh, da. All right, so here it is, guys. Here's how we do it. Ready? I'm doing the same thing again. So if I go, let me see if I can draw it perfect. Sum, oh, look at that. And I'm going to write 1 over, and I'm going to put parentheses. And it doesn't have to be J. It can be any letter. I'm going to write the letter K this time. And I'm going to write K minus 1 squared. Now notice what I wrote. I wrote K minus 1. So if I wrote K minus 1, that means I have to start at 2. And I have to end at 7. Let's see if this will give it to me. The first term, 1 over 2 minus 1 squared plus 1 over the second term. Well, the second term is as in, I have to start at 2, right? Start at x equals 2 or k equals 2. So the next one would have been 3 minus 1 squared. The next one, 4 minus 1 squared. 5 minus 1 squared. Keep going until you hit 7.
Wait, do you have to write the k equals
Oh, yeah, I do. In the first one, I have to write the k equals. You don't have to write it in the second one, the one in the top. Good job. All right, there it is, guys. And it's the same. It's the same. Cool or not cool, guys? Cool. It's the same. See? 1 over 1. 1 over 3 minus 1 is 2. 2 squared is 4. 4 minus 1 is 3. 3 squared is 9. 5 minus 1 is 4. 4 squared is 16. 6 minus 1 is 5. 5 squared is 25. 1 over 6 is 6 squared is 36. And it's the same. Same. So there's many different ways to express the same sequence. It doesn't have to be one specific one. And those that took statistics probably already know that. How many of you have already had statistics? Lanford, you already took stats, right? So this is basic for you. Mazuka, you already took stats as well? Oh. Okay. How many of you are taking statistics right now? Oh, no one? Okay. Statistics is a fun course, guys. You should think about it. Okay. Now we're going to try some on our own. So it says, let's try a couple more before we move on. This is where I start. And this is where I stop. So I'm going to go 1 plus 2 plus 3 plus 4 plus 5 plus 6. There it is. That's it. And if you want to add them all up, I don't know what that is. Let's see. 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 10. 10 plus 5 15. 15 plus 6 21. I got into 21. Someone find out if that's 21. All right, here we go on this one, guys. If you want to get ahead of me, go for it. 0 plus 1 plus 1 plus 1 plus 2 plus 1 plus 3 plus 1 plus 4 plus 1 plus 5 plus 1. Let's see what that is. 1 plus 2 plus 3 plus 4 plus 5 plus 6. Oh, it's the same thing. We did that on purpose. It's the same thing, guys. All right, let's do this one. We start at 3 and we stop at 7. So 3 squared plus 4 squared plus 5 squared plus 6 squared plus 7 squared. These numbers are too big for me to add up. You guys go for it. Tell me what those numbers are. Okay, I have a calculator. I'll do it.
135.
I was about to write it. 3 squared plus 4 squared plus... I know there's a command. So YouTube, if you're watching this and you're saying, man, why can't he just use the command? I'm not using it. Simple as that. You were right. Did you guess it or you already knew it? Oh, you just added it up in your head? Man, you're good, miss. I'm not scared. I could have done that too.
Sure.
All right. Uh-oh. This one doesn't have... Look what this one, guys. Start. Stop. This is an N. You can't do anything with that. That just stays as an N. 1 over N. 1 squared plus 1 plus 1 over N. 2 squared plus 1 plus 1 over N. 3 squared plus 1 plus dot, dot, dot 1 over n squared plus 1. And later on, we're going to be simplifying all these. This is a sequence. That dot, 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 3 dots in a row means keep going. And I should have put a plus, but I didn't. Keep going with the same pattern. And we're supposed to be able to simplify this. If you were calculus BC students, we would start simplifying it, but we're not BC students. We're not in Cal 2. So I'm going to leave that to your professor because I don't want to scare anyone. Are we still okay, guys? Okay. You can actually factor out. You see how every single term has a 1 over n? You can actually factor that out and do this 1 over n, and there it is, factored out. And we can go 1 squared plus 1 plus 2 squared plus 1 plus 3 squared plus 1 plus dot, dot, dot plus n squared plus 1. And I think that's safe to say without messing anything up for the Cal BC students. Oh. All right, next one. Start, stop. F of x1 delta x plus f of x2 delta x plus 3 of them, at least to start the pattern, x3 delta x plus dot, dot, dot plus f of x n delta x. That x does not have a superscript or a subscript. This is the x that has the subscript in the bottom. Yes, just like before, if you want to factor out the delta x, you can, guys, because they're all the same. But I'm going to leave it like that. Is anyone confused? Okay, let's see if we can apply it. Uh-oh, what do I do on this one? Relax, guys. First, worry about this guy. So let's see. I'm going to put an equal sign. I'm going to erase that period. And there it is. There's my equal sign now. There's no more period. And I start at k equals 1, and I stop at k equals 5. So f of 1/2 plus 3 plus f of 2 over 2 plus 3. Yes, I know that's a 1. We'll change it right now in a little bit. Plus f of 3 over 2 plus 3 plus, oh man, I don't have enough room, guys. F of 4 over 2 plus 3 plus f of 5 over 2 plus 3. So what does this mean? So let me see if I can draw it perfectly. From k equals 1 to k equals 5 of f of k over 2 plus 3 means 1/2 plus 3, that's 3.5. F of 3.5 plus 2 over 2 plus 3, that's f of 4. Plus 3 over 2 plus 3, that's 1.5. So that's 4.5. Plus, and you can already see the pattern. 4 divided by 2 is 2, 2 plus 3. And then last but not least, f of 5.5. So now what are you going to do? You're going to find these guys. You're going to find them. F of 3.5 equals -2 times 3.5 plus 3. Viacana, find me this one. We're all going to do one. F of 4, -2 times 4 plus 3. We can, that one, no one need, I can do that one. 4.5, -2 times 4.5. That one's another easy one. 5 I guess they're all easy. We'll get them right now, guys. All right, let's see. Negative 2 times 3.5, that's negative 7. Negative 7 plus 3, that's a negative 4. Is that what you got, Viacana?
Yes.
Awesome. 2 times negative 4 is negative 8. Negative 8 plus 3 is a negative 5. Negative 2 times 4.5, that's a negative 9. 9 and 3, that's a negative 6. So I'm going to assume that's negative 7. 4, 5, 6, 7, and that's negative 8. 11, 1, 2, 3. Yep. All right, add them up. There it is. No, I'm sure you're right, miss. 8, 5, 4, 9, 15, 15, and yeah, you're right. All right, guys. Last one. It's the same thing again. So evaluate this first. K equals 1 to 4 of f of 3k plus 3. So we start at 1. So f of 3 times 1 plus 3 plus f of 3 times 2 plus 3. We're always doing integers on this. That's how I use the summation. F of 3 times 3 plus 3. And finally, f of 3 times 4 plus 3. So let's see what that is. 3 times 1 is 3. 3 plus 3 is 6. 3 times 2 is 6 plus 3 is 9. 3 times 3 is 9 plus 3 is 12. So the pattern is by threes, right? 3 times 4 is 12. 3 times 4 is 15. And we find those again, guys. And you just come here to the side. F of 6 equals 6 minus 4. F of 9 equals 9 minus 4. F of 12 equals 12 minus 4. And it's going by 3. Obviously, right? Because it's a linear expression. 15 minus 4. All right. All this added together, 11 and 8 is 19, plus 5 is 24, plus 2 is 26. What's up?
Are they really gonna ask us to do this on anything then?
They'll ask you, not this. This is leading up to what they're gonna be asking us. I'm sorry, miss. Y'all like what we're doing tomorrow. We're gonna connect this to the integral symbol. All right, guys, let's all come back. Well, you guys are already back.